such a word, such for the great welcome. Now moving ahead for our next technical session. And for the next session, I would love to invite Dr. Hemang Patel from 20 Microns Limited. And the topic of the session is Smart Mineral Engineering for Paint Performance. Can we all clap together for Dr. Hemang Patel? Thank you so much.
Hello everyone. Very good afternoon. Namaskar. Radhe Radhe. I would like to thank you, Paintvision entire committee and sponsors who have provided me very good facility for this presentation. And presentation is after lunch, so it is very difficult to sustain during the presentations. And two things happening most after post-lunch. One is your mind is negotiate with your eyes. And another is paint raw material cost is day by day increasing. So the first one, challenge cannot be solved with the cup of tea. But for the second challenge, as a research, it requires innovations. Same thing, how we can see at a different way. So I will looking forward to talking with you beyond fillers, smart mineral engineering for paint performance. So we have very good R&D center, and we have total 39 years of the experience. And in R&D center, it is recognized by DSIR, Department of Science and Industrial Research. And in R&D center, we have the sophisticated instrument for the measurement of various physical and chemical properties of the minerals. As well as we have very good paint application centers. So in paint application center, before providing any grade to customers, we first develop its tentative paint formulation using our grade. And if we satisfy using that, then and then we provide our grade to customers. So these are the content of the today's topic. So we have Sheen and Gloss Enhancer. Basically, it is a calcium carbonate. We will discuss one by one. Then engineered aluminum silicate. We have the Pulglan. It is a hydrous kaolin, and Hyperglan. It is a calcine kaolin. Then white pigment opacifier. It partially replaces TiO2 in paint formulations, water-based paint formulations, and solvent-based paint formulations. Then we have the anti-corrosive pigment. So recently we have filed a patent on that. So it replaces 100% zinc phosphate in the marine coatings. Then we have buff and gray color rutile TiO2 for the color-based paint formulation in replacement of the white rutile TiO2. Then we have very good inorganic co-thickeners, and we provide guaranteed 50% of organic thickener replacement in this. Then we have the organoclay for the solvent-based series. Then we have matting agent based on the precipitated silica, fume silica, and natural diatomaceous earth-based silica. And then we have the wax emulsion based on the polyethylene, polyamide wax, FT wax. So I will start with the Milglan. So basically it is a calcium carbonate. But this calcium carbonate, basically paint manufacturers, how they use? They utilize for the cost reductions, PVC adjustment, and volume extension. But as a scientist, do I have prepared a good material which gives the sheen value as well as which gives the matte value? Or as a paint manufacturer, do I have utilized the calcium carbonate in a different way for the individual paint formulations? Now you can see this calcium carbonate, it provides the high gloss, semi-gloss, satin finish, and matte finish. So how single calcium carbonate will provide this different type of property? So we have performed surface engineering on the calcium carbonate. So if we require the gloss, then we do make the surface of calcium carbonate very smooth. Or in case of the matte, we prepared a porous structure. So you can see calcium carbonate हर एक जगह मिलता है, प्योरिटी भी 98, 99 मिलती है, फिर भी कभी कभी रिजल्ट नहीं आता. कभी कभी प्रॉब्लम होता है ना कि मैं तो इसका कैल्शियम कार्बोनेट यूज़ करता हूँ, प्योरिटी भी सेम है, वाइटनेस भी सेम है, फिर भी मुझे रिजल्ट नहीं मिलता. तो मेन रीज़न उसका मॉर्फोलॉजी है, स्कैनिंग इलेक्ट्रॉन माइक्रोग्राफ. सो यू कैन सी आई हैव प्रोवाइडेड वेरियस रीजन ऑफ द scanning electron micrograph of the calcium carbonate. So during the preparation of our grade, we choose calcium carbonate mines in such a way that it provides the property in your paint formulations. So you can see we have prepared one paint. You can see premium emulsion paint, in which against the regular calcium carbonate around D50 2 to 3 microns, and Milglen has D50 around 0.8 to 1.2 microns. So we have focused on the particle size distribution. You can see over here. Particle size distribution is very narrow in case of the Milglen. And you can see how much scene we have observed. So against the regular calcium carbonate, we have observed very good amount of the value of the scene as well as opacity. Then we have prepared a dust-proof exterior paint, in which against the standard we have replaced 50%, 25%, 20% and 25%. So this replacement is using the LC1465. I will explain LC series in my upcoming slides. And after that, we have added the Milglen to achieve the properties against the standard. So by this way, you can also utilize or modified your paint manufacturing process. And what we have observed, if we replace 25% TiO2 and add Milglen, then one can save 4.26 rupees per liter of the paint. So it is a very good saving in terms of the extendeds. Then we have prepared one stucco paint. So in stucco paint, we have taken our O-carb, and against the O-carb, we have added Milglen. So you can see the properties. We have observed 54% higher gloss, 15% higher gloss at 60 degree, and also lower trowel hand effect required if you utilize the Milglen. Then in solvent-based paint, we have replaced 20 and 30% TiO2 with the help of lithomer tox, and we have added the Milglen. Why we have added Milglen? To maintain the gloss value in the solvent-based paint formulations. So you can see after 20 and 30% replacement of the TiO2, we have observed very good gloss value as well as maintain the opacity. Now another series is ultra-fine hydrous kaolin. You can see we have a very good magnet at our Bhuj location. We have our own mines of the kaolin. And this Bhuj location has 5 Tesla magnet. It works at minus 260 degrees Celsius. So it has the ability to remove magnetic paramagnetic impurities. So using this magnet, we can able to remove the maximum iron impurities. You can see this is a white slurry of the kaolin, and how brown color slurry looks like, you can see. So we increase the whiteness and brightness of the kaolin material after the purifications. And this pearl glass has particle size very fine. You can see 150 nanometer to 350 nanometer. So due to fineness, it gives the scene value as well as it has a lower under yellow tone. So which is the USP of this product. And you can see we have prepared one economy mid PVC paint. And against the conventional kaolin, we have utilized our Perlglen. And you can see the yellowness value. So in conventional, we have observed the 7.54 yellowness, while in case of the Perlglen, we have observed 5.28. So you can utilize maximum amount of the hydrous kaolin in your paint formulation. Due to yellowness, one cannot utilize higher percentage of kaolin in paint formulation. But if you are utilizing the Perlglen, then you can add maximum dosage in your paint formulations. And we have prepared a high glossy, low PVC paint. You can see percentage PVC is very low, approx 13%. And against this standard, we have observed very good sheen value as well as opacity value with the 20% replacement of TiO2 using LC1465. And by this way, we have observed approx 7.82 rupees cost saving on the extended per liter of the paint. Then we have a calcine kaolin, and it is a hyperglane. Now, most of the calcine kaolin provides the satin effect and matte effect. But this hyperglane provides a gloss effect as well as the dry hiding. How we have prepared? So, we calcine the kaolin materials. But after the calcination, we do systematic cooling of that material. So we maintain its structure. During the calcination, its structure has been disturbed. But using this calcination technology, because it is attached with the SCADA systems, so using the SCADA system, we get the all properties related to its morphology. And using it, we have developed this very good hyperglane. And hyperglane has also very fine particle size. And this hyperglane has ability to replace opaque polymer. And you can see the data. We have compared this hyperglane against our Glazex 90. And after that, we have replaced 5%, 10% TiO2 using the hyperglane, as well as 100% replacement of the opaque polymer. So it gives very good sheen value, as well as opacity is also drastically increases. So in mid PVC interior paint, you can see the property. So against the standard opacity data, as well as we have replaced 15% TiO2 and 100% opaque polymer. And you can see that we have observed 7 rupees cost saving per liter of the paint using hyperglane. Now Hyperlight EST, it is also engineered kaolin. So it has ability to replace 100% zinc phosphate. So how it replaces? So it has a hexagonal structure, as well as we have produced this Hyperlight in such a way that its aspect ratio is very high. So due to high aspect ratio, its structure is aligned parallelly to the resin film. So it will not allow to pass moisture and oxygen inside the substrate. And by this way, it will protect your paint substrate. So we have performed one epoxy paint, and in which, in standard, we have utilized 8% zinc phosphate, and against the standard, we have utilized 8% Hyperlight EST+. So 1-to-1 replacements. And then we have checked the anti-corrosion property using ASTM B117. And we have observed very good results. So 100% zinc phosphate, it will fail after 800 hours, while in case of Hyperlight EST+, it gives the 900 hours without any failure. So using that, we have observed 20% cost saving per liter of the paint. Now we have very good series of the LC series. So basically we do the coating of the TiO2 on the calcium carbonate, but how we'll do and how we'll check. So you can see we have the facility to check the zeta potential value of the materials, but whenever your paint contains the extendeds and pigments, but through naked eyes that cannot show. You can see using the instrument that continuous continuously movement, you can see. So what is our main objective is to stop that Brownian motion of the all pigments and materials. So it is very difficult to control that Brownian motion, but using the instrument, you can see. And to stop that Brownian motion, you have to use certain additives. So that additives, it will stop the Brownian motion. And after that, if you utilize this paint, it will give very good hiding data, as well as the desired gloss and matte finish data. So you can see using the additives, it will stop the Brownian motions. And we are continuously getting this data. This is a rail laser. It has a 620 nanometer wavelength, and using that, we are continuously getting the data. And it will give the ZP value, zeta potential value of our slurry. So we prepared a slurry with the chemical reaction. And after that, we check all the data. And also, we provide electric charge to the slurry. So what is the behavior of the material? You can perfectly get the details. So we have LC1465, LC80, and LC460. So we do the TiO2 coating. And using the TiO2 coating, one can get the replacement of the TiO2 and cost effectiveness in paint formulations. Now another important thing is, customer basically asks to us, what if I mix TiO2 powder and calcium carbonate? Definitely you can mix, but you have to also check the specific gravity of both the materials. So TiO2 has a very high specific gravity, while calcium carbonate has very low specific gravity. So if you mix both, you will not get the exact data. So I have also explained with the help of the two lasers. So you will not get the proper van der Waals force of the attraction. So कभी-कभी क्या होता है कि साहब आपका मटेरियल तो यूज़ किया, एक बार हाइडिंग अच्छी आई, दूसरी बार नहीं आई. तो ये कंटिन्यूस प्रॉब्लम फिजिकल ब्लेंडिंग में होता है. बट व्हाट वी डू द केमिकल प्रेसिपिटेशन टेक्निक, एंड वी ऑल्सो यूज द रोटर स्टेटर टेक्निक टू गेट द वेरी फाइन पार्टिकल साइज डिस्ट्रीब्यूशन ऑफ द मटेरियल्स. You can see how single particle look like. It is around 200 to 400 nanometers, very fine particles, equivalent to the TiO2. And also we have performed the element mapping analysis, and you can see pink is the titanium and green color for the oxygens. So for the white color, you cannot see white dot visible. It means TiO2 has coated the calcium carbonate. And using the TiO2 replacement, using LC1465, so we have replaced up to starting from 15 to 30%. And we can say up to 25% TiO2 replacement is possible using LC1465. And you can observe 4 rupees cost saving per liter of the paint. Then lithomer talks, it is also we prepared by co-precipitation technique of barium sulfate titanium, and you can save approx 15 to 20% TiO2 in solvent-based paint formulations. So overall, this LC series, it is a partial TiO2 replacement, and it is a cost-effective than titanium dioxide. Now we have buff and gray color rutile TiO2. Basically, we process this from the ilmenite minerals, and how it look like. So for the color-based paint formulation, you can utilize or you can replace this white TiO2 and some of the pigments, and you can utilize our buff CTOX series and GTOX series. So we have prepared one saffron yellow RAL1017 using the CTOX H. And after drawdown at the room temperature, we have kept that drawdown at 241 degrees Celsius in order to check whether its color is faded or not, because this is an inorganic materials, so its color will not faded. And similarly for the gray shade, we have various gray shade in terms of 7044, 7045. And using this gray shade, we have prepared light gray RL7035 and 7023, in which we have utilized minimum amount of the TiO2 and replaces some of the pigments. So this overall buff and gray color rutile TiO2, it has a very good particle size, and due to the inorganic nature, it will not react with any resin systems. Now another very good series is the hydroxy gel, because it has ability to replace 50% of the organic thickener like HEC, SCMC. So you can see in R&D, we are continuously focused on the cohesive forces, and these cohesive forces particularly work depends on the hydrogen bonding, van der Waals force of the attraction, and dipole interactions. So everything around us, it is prepared by the tiny molecules. And these tiny molecules are attracted towards the cohesive force. So we do the modification of the bentonite materials. And this bentonite processing we do at a wet process. And after that, we dry, filter press, and produce this hydroxygel series. So you can see water follow the non-Newtonian law. Whatever the pressure we can apply shear force, its viscosity does not change. But in case of our materials like bentonite materials, even carboxymethyl cellulose, its viscosity changes based on applied shear force. So as a paint manufacturer, you have to utilize this material in such a way that it will give you proper viscosity data. So this is a bentonite material you can see, and we increase the distance between two plates during the manufacturing process, and if you utilize this material, it will definitely gives you very good viscosity data. So we have prepared a 2% gel of the HEC and hydroxygel A1. HEC gives viscosity around 38-40,000 centipoise, while hydroxygel A1 gives greater than or equal to 7 lakh centipoise viscosity. Of course, HEC is a transparent gel, while in case of A1, you will get the opaque jelly. And after utilizing that in low PVC paint and mid PVC paint, we have replaced this 50%, and we give the guarantee to replace 50% of the HEC. And after preparation of paint, we have diluted with 30% water, and we have checked the gauge of that paint, and we have observed similar gauge equivalent to the HEC. This is for the mid PVC paint. So for low PVC, mid PVC, it works extraordinary. And also we have prepared one rustic texture paint in which we have replaced this 100% HEC, and you will get very good smoothness, no lumps, and no phase separation after we have put that paint in oven for the 45 degrees Celsius for 1 month. So this hydroxygel, it is a very good grade and provides very good pigment suspension and replacement of the organic thickeners. Now another series is the hydroxygel A4W. So we have performed some surface modification by considering the data of the MHEC. So what MHEC will do, it increase the open type, it provides very good bonding strength. So similarly, we have performed or do the modification on our bentonite material, bond monolite material. And in cementitious wall putty, it replaces clearly 50% of MHEC in putty applications. And after that, we have checked with wet and dry rubbing. And we have not observed any choking effect using the hydroxygel A4W for the replacement of MHEC. Then another series is the Rioband. It is basically organoclay. So basically it is also monobolite, and when you use bentonite material, its surface carries the negative charge. So what we do, we increase the distance using the sodium. Sodium is a monovalent cation, while calcium is the divalent. And we do modification using the quaternary ammonium compounds. So using the quaternary ammonium compounds, it becomes the hydrophobic in nature. And after that, if you utilize for the solvent-based paint, it gives the very good thixotropic properties. So we have launched this Rioband IC, and it is a very easily dispersible material, organoclay, and it can be utilized in high solid, solvent-based, heavy-duty, anti-corrosive coatings. And also we have performed one small experiment in our paint application lab. And you can see the data. We have checked the stability. And we have observed very good stability and sag index using Riobent IC. And remaining grade, we have Riobent 3452, Riobent 38, Riobent SD. It works low to mid polarity of the solvent-based systems. Then we have the silica, that silica based on the precipitated silica, fume silica, and natural diatomaceous earth-based silica. So this fume silica, it provides the transparency, rheological property, as well as the matting effect, while precipitated silica, it gives the matting effect and viscosity control, and diatomaceous earth-based silica, you can see all are structure very different, and it gives very good dead make effect in your paint formulations. So based on the requirement, we provide our grade to customers. And this is amorphous. Amorphous, basically, it is a diatomaceous earth, and it gives perfect dead matte effect in paint formulations. So this is overall about FM seal and fusil, precipitated silica and fume silica. It also increases the hardness of the surface. Then we have the wax and wax emulsion. So basically we have categorized wax in two categories based on the applications. One is the ink applications and one is the paint and coating application. So for paint and coating application, we have the flow wax series. And in wax series, we have polyethylene wax, polyamide wax, PTFE wax, and vegetable-based amide-based wax. And we have categorized based on the particle size and the melting points. And also we have the emulsion based on the polyethylene wax and paraffin wax and hydrocarbon wax emulsions. So it gives very good scratch resistance, mar resistance in your paint formulations. So overall, we provide our various grades for the TR2 replacement, for the rheological property, for the matting effect. So some of our grades are eco-friendly, and some of that provides very good rheological properties. And we have very good micronization. Micronization in terms of the wet grinding as well as the dry micronization process. So thank you very much. If you have any question, you can ask me.
Thank you so much, Dr. Hemang Patel, for such a wonderful session. Now, for showing us some small gesture or a memento towards Dr. Hemang Patel, I would love to invite Mr. Amit Bhatia from Premium Pigment. Mr. Amit Bhatia from Premium Pigment. Thank you so much, both of you, for your wonderful time. Thank you so much.